Hello, my dear friends and my students. This is the second part of the chapter Haloalkane and Haloarenes from class 12. That is the part from organic chemistry for the aspect of NEET, JEE exam, and for your board examination also. This is the second part. So you just go to the channel and you find the first part. So you just understand the first part, that is the introduction part, which is most important for to understand these things. Okay, so let's start our second part from the chapter Haloalkane and Haloarenes. So first here this is the preparation of haloalkane. Okay, we start from the preparation of haloalkane. So first is from alcohols. So from alcohols, how can you prepare haloalkane? So we study now these things here. Okay, so first of all, this is by the action of halogen acid. Halogen acid means HX, means like HBr, HI, HCl, etc. Okay, so first of all, see, this is an alkyl group. Okay, R is the alkyl group, and alkyl group is connected with which? This is nothing but an alcohol. So alcohol reacts with HCl in presence of anhydrous ZnCl to form RCl and your water as byproduct. So RCl means alkyl chloride. Okay, so after that, see, here we write for the case of primary and secondary alcohols. For the case of primary and secondary alcohol, we use anhydrous ZnCl2 and we get the halogen haloalkane. Okay. The second case is from tertiary alcohol, and if we use a tertiary alcohol, it is not required to use a catalyst anhydrous ZnCl2. We can do the reaction in room temperature and we get the desired product, and also we get water as byproduct. Okay, byproduct is not so important. The main product is important. You have to remember the main product. So here I am giving some example. See, this is a primary alcohol, CH3CH2OH. Okay, this is a primary alcohol. Why it is primary alcohol? This is very similar as haloalkanes. That OH group connected with this carbon atom, and here this carbon again connected with one carbon atom only. That's why this is primary alcohol. And this primary alcohol, when reacts with HCl in presence of anhydrous ZnCl2, and we get CH3CH2Cl. So why it is required to use anhydrous ZnCl2? Here this anhydrous ZnCl2 is actually a Lewis acid, and where it is act as a catalyst here, and it is first of react with this. Okay, here we have C bond O bond. Okay, so the anhydrous ZnCl react with this, and this bond we can and very easily means break down, so that C bond Cl bond will form. Okay, so this is actually for the case of primary, and this is secondary. For both two cases, anhydrous ZnCl2 is required. But in the case of tertiary, this is actually tertiary. In the case of tertiary, see why this is tertiary? Because OH bond OH is connected with this carbon atom, and this carbon connected with three different carbon atoms. Okay, that's why this is tertiary. And when it is actually this with reaction will carried out at room temperature only, because the tertiary one is the very stable one. Okay, we know that about the carbocation. If we actually the reaction is carried out with the formation of carbocation here. Okay, and we know that from class 11, that is from GUC, that a tertiary carbocation is more stable than secondary than primary. Okay, so tertiary one is the more stable one. So if we see here primary, secondary, and tertiary, so tertiary one is the stable stable carbocation. That's why this reaction will carry out at the room temperature only. Okay, so and we get the desired product. So these reactions are actually just note down these things. So in presence of and we use anhydrous ZnCl2 zinc chloride. For the case of primary and secondary, this is important, and for the case of tertiary, it is not required to use anhydrous ZnCl2. At room temperature, this reaction will completed, and we get the desired product. Okay, this is important. You just remember these things. Okay, after that, say you have one compound like say you have this is from haloalkane. Say you have CH3 CH2 CH2OH. Okay, and when you give HCl to this reaction in presence of anhydrous ZnCl2, then you get the product CH3CH2CH2Cl and water as byproduct. Okay, now I give you and again another example. I give you CH3CH2CH3OH plus HCl. Then at room temperature you get the product CH3CH2CH3Cl plus water. Now I'll give one question to you, that if you have CH3OH, okay, so this is CHOH, then say you have, say this is your CH2OH, okay, this is CH2OH, and you give HCl and anhydrous ZnCl2, and what is the product? So you may say that the product is very simple. The product is CH3CH2Cl plus water. But this is the wrong one. This is not the correct one. Okay. So why this is wrong? See, actually what happened, if we see the mechanism of the reaction, actually what happened, we see, first of all, that is anhydrous ZnCl2 react with the COH bond to remove the OH from here. Okay, and if OH remove here from here, this in this carbon atom, carbocation will form like that. Okay, CH2 plus. This is the first step. Okay, so in the first step, carbocation will form. And when carbocation will form, and in the second step, that the Cl minus, which is nucleophile, act here. Okay, react with this carbon atom to form the product. But see, what is the degree of this carbon? This carbon is 1 degree. Okay, and see the adjacent carbon. This adjacent carbon is actually 1, 2, 3, 4. This is 4 degree quaternary. Okay, so we know that for the case of carbocation, the 4 degree one is the most stable one, then 3 degree, then 2 degree, then 1 degree. We know this one from class 11. So as this one is the most stable one, when carbocation form in this carbon atom, immediately comes here. Okay, this carbocation immediately comes here, and from here any one of this CH3 methyl group goes here. Okay, and after that, you get after that what you get from here, you get a CH3 here you get the positive charge, and CH3. This CH3 comes here. Okay, so now see, now this Cl minus, okay, H plus and Cl minus, you have this Cl minus, okay, react here, and you get the product CH3Cl, then CH2CH3. This is the final one, and here this one is called 1,2 methyl shift. Okay, 1,2 methyl shift. So this part is the most important part. You have to remember this thing. Okay, so very similarly, say if you have one question like that, say you have CH2OH, okay, and you give HCl in presence of anhydrous ZnCl2, and what is the product? And here the product is CH3CH3Cl This is the product. How? You can say this from this OH will remove, then we get a Cl here. No, actually again here the fundament of carbocation. Okay, see here this is CH3 after first step. In the first step, CH3 CH2 plus will form. This is the carbocation, and now this carbocation shift here, okay, in this carbon, because this is 1 degree actually, and this is actually 1 to 3 degree, okay. With this carbon atom we have hydrogen, and when carbocation shift here, this whole hydrogen goes here, okay. Then this is called 1,2 hydride shift, 1,2 hydride shift, okay. So after that, when it is means hydrogen comes here, then it will form CH3, CH3 plus, then CH3. Now Cl minus attacks here, okay, and you get this product, okay. So you have to remember these two things, the shifting, that is 1,2 hydride shift and 1,2 methyl shift. These two part is important. This is also important for your joint entrance examination as well as for your board examination, okay. This thing means these things, the 1,2 methyl shift and 1,2 hydride shift, these things will happen due to the carbocation stability, okay. Remember these things, due to the carbocation stability, and we know that the 4 degree carbocation is more stable carbocation than 3 degree, then 2 degree, then 1 degree. These things we have to remember, okay. Now after that, from alcohol, okay, from alcohol we have to prepare halogen acid, like we want to prepare RBR, we want to prepare RI, this one, okay. So to prepare RBR and RI, see, if you have say one alcohol like ROH, okay, and if you give HBr here, okay, in presence of concentrated H2SO4, then you get RBr, okay, as product. Now see here, this HBr is actually in situ. In situ means, what is in situ means, this HBr will form during the reaction. Means actually what happened, your alcohol reacts with KBr in presence of concentrated H2SO4, okay. This KBr and concentrated H2SO4 when reacts each other and form HBr, and when HBr will form, then that HBr will react with alcohol and form the product RBr, okay. Very similarly, for the case of RI, say you have ROH and you give HI in presence of H3PO4 phosphoric acid, then you get RI as your product. So here also this HI is also in situ, okay. During the reaction it will form how, see, you have ROH and you give Ki in presence of H3PO4, then you get RI as your desired product. So you can take some examples. So examples like say you have you have CH3CH2OH. This is ethyl alcohol, and this ethyl alcohol react with KBr in presence of concentrated H2SO4, then you get the product CH3CH2Br, okay. Very similarly, you can write the same reaction as like this, CH3CH2OH plus HBr in presence of concentrated H2SO4, and you get CH3CH2Br. And say if you have CH3CH2OH in presence of Ki and H3PO4, okay, phosphoric acid H3PO4, and you get the product CH3CH2I, and you can write the same reaction as like that, CH3CH2OH plus HI in presence of this, then you get H3PO4, then you get CH3CH2I. Remember, this HI will form in situ for this reaction when Ki and H3PO4 reacts each other and form HI. Very similarly, when KBr and H2SO4 react each other and form HBr. So this HBr is in situ in this reaction, okay. Okay, so from alcohol, so by the action of halogen acid, we prepare these haloalkanes. Next one is, so from alcohol only. So the next one is from by the reaction of phosphorus halide, okay. By the reaction of phosphorus halide, like say you have by the reaction phosphorus, like you have ROH means alcohol, and you react with phosphorus halide, like say you react with PCl5. Okay, PCl5, this is phosphorus halide. Okay, then you get RCl as a byproduct, as product. Okay, and if you react the same thing with PCl3, then you get RCl. Okay, and if you react the ROH with Pi3, then you get Ri, and if you react with PBr3, then you get RBr. Now you can replace R group with any alkyl group. Any alkyl group means you can use CH3 group, you can use CH3, CH2 group, whatever the alkyl group is. So whatever, if you replace this R group with CH3, CH2, you also replace this R group with CH3, CH2. Then you get different kinds of alkyl halides when you replace this R group with a different alkyl group. Okay, so these things are very important. Okay, and here this Pi3 and PBr3 is also in situ, and this Pi3 is actually unstable and PBr3 is also unstable. That's why they are prepared in situ during the reaction with different reagents. Okay, now again these things will react with alcohol, reacts with SOCl2 means thionyl chloride, then you get RCl. Okay, and if we compare this PCl5, PCl3 and these things, you can say among these reactions, okay, means all these things are, this is phosphorus halide, this is thionyl chloride. So we use phosphorus halide and thionyl chloride to get the different halogen halide. Okay, means alkyl halide. So which among these reactions, among these reactant with PCl5, PCl3, SOCl2, PBr3, Pi3, so if we react with these, which one is the best one? Okay, which one is best? Because see, actually the product formed here in the byproduct formed here in this process are actually, they are not gas, they are actually a liquid, or they are miscible in the solution with this. Okay, but here the byproducts are, okay, here the byproducts are SO2 and HCl, and SO2 is actually gas and HCl is also gas. So when SO2 and HCl are removed from this reaction, then you get RCl only as product. Okay, but the byproducts are removed from the reaction. Okay, byproducts are removed from the reaction, so you get RCl only. This is the pure one. Okay, so you can say that the reaction of alcohol with a thionyl chloride is the best process to get the alkyl chloride. Why? Because the byproduct from here, that is the sulfur dioxide and HCl, are gas at room temperature, which will remove out from the reaction medium, and we get the alkyl halide as pure one. Okay, that's why this thionyl chloride process is the best process among these. Okay, so this is the reactions from alcohols. How can you prepare the alkyl? Okay, alkyl halide from alcohols. These are the reactions from alcohols and this. Now one thing you have to remember, that from alcohol, when you react the means HX and all these things, that tertiary alcohol react faster than secondary than primary. You have to remember this. Tertiary alcohol react faster than secondary than primary. Okay, and another thing you have to remember, that HI will react faster than HBr than HCl with alcohol to form the desired product. You have to remember these two things. These two are most important. That tertiary alcohol react faster than secondary than primary, and when you react with HI, HBr and HCl with the same alcohol, the HI react faster than that of HBr than that of HCl. Okay, considering that with say this thing will react with primary alcohol, then you get the means primary halide with HI faster than HBr than HI. Why you can say? Then you can say that this I are the bigger in size, so this nucleophile, this bond is very weak and easily removed, and this will attack faster than HBr than HCl. Okay, because HI in iodine, the size of the iodine is the bigger one. Okay, size of the iodine is the bigger one compared to Br. okay, and compared to Cl. So you can say that as iodine has the bigger in size, though Hi will react faster than HBr than HCl. Okay, so these things you have to remember. Okay, fine. So then from this is from alcohol, and after that we'll go from second one. Second one is from hydrocarbon. Okay, from hydrocarbon. Hydrocarbon say means say if you have CH3CH3. Okay, this is ethane. Okay, you react this with chlorine in presence of UV light. Okay, in presence of UV light, then you get the product CH3CH2Cl plus HCl as byproduct. Okay, now say if you have again, if you react this one again which is chlorine in presence of UV light, then again you get a CH3CHCl2 plus HCl. In this way you get a different products by replacing one hydrogen by one chlorine atom. Now if you have this compound CH3CH2CH3 plus Cl2 UV light, so what is the product? Okay, in this case you get two different product. First of all you get a CH3CHCl CH3, this is one product. Another one is CH3CH2CH2Cl, and you remember this one is the major one and this is the minor one. Why this is minor and why this is major? Because see, this carbon is 2 degree and this one is 1 degree, this one is also 1 degree. So 2 degree will form the stable product than that of 1 degree, and you have to remember this thing. Okay, so after that, one thing you have to remember, that which you already studied in class 11, that if you have say like if you have methane, okay, methane CH4, okay, and you react with Cl2 in presence of sunlight. Okay, in presence of sunlight, first of all you get a CH3Cl plus HCl as byproduct. Okay, this is after that, when this is methyl chloride, you remember the CH3Cl is methyl chloride, and when again you react with chlorine in presence of sunlight, then again you get a CH2Cl2 dichloromethane plus HCl. Okay, and again you give a Cl2 in presence of sunlight, then you get CHCl3 plus HCl, this is chloroform, and again if you give chlorine in presence of sunlight, then you get a CCl4 plus HCl. So this CCl4 is nothing but carbon tetrachloride. Okay, so see, from this methane you get different products. Okay, and they can be separated. Okay, they can be separated from their mixture because of their different properties, different melting and boiling points properties, so that they can be separated from here. Okay, see, if you write that methane plus 4 Cl2 in presence of sunlight, okay, in presence of sunlight, okay, then what is the product? Your product is CCl4 plus 4 HCl, you can write directly. Okay, see here, in the first part you use one chlorine, in the second part you use another chlorine, third part third chlorine, and fourth part fourth chlorine. So first, second, third, fourth. So when you use fourth chlorine as a whole, then you get this product, and in each step you get HCl 1, 2, 3, 4 HCl. So this is your product. Okay, so you have to remember these things. This part is also important. Okay, so after that, so second part, that is this is actually from hydrocarbon. So the second part is, so before to start the third preparation of haloalkane from hydrocarbons, we have to understand these things, that reactivity of different types of hydrogen in halo compounds. Okay, so see, we know about this benzylic, allylic, alkyl, vinyl and arylic. These things will explain in the first part of this chapter, that is the introduction part. You just go through the channel and you find the first part of this haloalkane and haloarenes, and here in that video that will discuss about this benzylic, allylic, alkyl, vinyl and allyl. Okay, see the reactivity of different, if the hydrogen is the benzylic one or allylic one, they have the similar reactivity than that of alkyl, vinyl or allyl. Okay, so see here I give you one example, this CH2 double bond CH bond CH3. Okay, and if you react this with Cl2 in presence of this 773 to 873 Kelvin at gas phase, then what you get? You get the product that allylic one. Okay, this is actually allyl. Why it is allylic? This halogen is connected with this carbon atom, and this carbon is connected with a double bond system. That's why this is allylic. So in this type of reactions, your product should be allylic. Okay, and here see this one. This is actually nothing but toluene, and this is when react with the bromine Br2 in presence of light, and if you go for the reflux, then you get the benzyl bromide. Okay, this is benzylic one. Okay, this CH3 is here the hydrogen is most reactive hydrogen other than these hydrogens. Okay, that's why you get this product. Okay, this one is the benzylic one. Okay, very similarly, see the same reaction when you do this reaction with N-bromosuccinimide, which is called NBS in shortly. Okay, the same condition in presence of sunlight, then you get the same product. Okay, same product. This is also a allylic one. Okay, this is also allylic bromide, and this is your byproduct. You remember this thing. And if you do the same thing with SO2Cl2 with these conditions with a trace of peroxide, and you get the allylic one also. So you just remember that the allylic or benzylic, okay, allylic or benzylic hydrogen are the most reactive hydrogen, and they give the allylic product or benzylic product. Okay, so similarly one example is here. See this example. Here, this one, okay, this one. So what you guess? What should be the product for this case? Just you guess, and you try to solve this. Okay, what is the product for this case? Okay, I think you solve this one. The product for this reaction, the product is, you can give Br. Okay, here also, whatever. Okay, this is also allylic. Okay, this is also allylic because see this halogen connected with this carbon atom, and this carbon is connected with a double bond system. Okay, that's why this is allylic. So this is your product. Okay, this is your product for this case. Okay, understand this thing? Okay, next go to the next part. Next preparation of haloalkane. Okay, and this preparation is this number C. Okay, preparation from alkene. Okay, from alkene. Okay, say you have a CH2 double bond CH2 ethene you have, and react with HX, and here you use HBr, HCl and HI, means X is equals to chlorine, bromine or iodine. Okay, then you get the product CH3 single bond CH2X. Okay, this is your product. Okay, see actually here in HX you get H plus and X minus, and this X minus, say this attack here, and this double bond goes here. Now if double bond comes here, this is now it is negatively charged. This negative charge will attack H plus, and you get this product. This is the mechanism. Now you have to remember one thing here in this part. This is the CH2 double bond CH2. This is a symmetrical alkene. This is a symmetrical alkene. If you do the same reaction with an unsymmetrical alkene, then what is the product? Okay, say you have unsymmetrical alkene. I think you got the point, and this thing we already explained in class 11 in the hydrocarbon chapter. Okay, see if you have CH3 CH double bond CH2, this is unsymmetrical one. Okay, this is unsymmetrical alkene. Now in this, this is unsymmetrical. Why this is unsymmetrical? We all know that. See the double bond. Here among these two carbon atom you have double bond, okay, and here in this carbon atom you have two hydrogen, but here you have one hydrogen and one CH3. Means among, if you consider these two carbon atom with the double bond system, the means hydrogen atom here and hydrogen atom here not same one. That means they are not same, so that is unsymmetrical. Okay, so if you react this with HBr, or you can use HCl, you can use HI. Generally HBr are generally used. Then you get CH3, okay, CHBr bond CH3 as one product, which is a major one, and another product you get CH3 CH2 CH2Br. This is a minor one, okay. See, this product, this is near about 90% and this is actually 10%, okay, and these two products is according to the Markovnikov rule, okay. Where HX reacts with an unsymmetrical alkene, according to Markovnikov rule, the negative part will attack into that particular carbon atom of the double bond system which has less number of hydrogen atom. Okay, so among these two carbon atom, this carbon has two hydrogen and this has one hydrogen. So means this carbon has one hydrogen, and that's why the negative part of here in HBr, negative part means the Br, okay, Br1, that will attack into that particular carbon atom among these two which have less number of hydrogen atom. Okay, so that's why this is the major product and this is the minor product. Okay, now if you do the same reaction, so you have CH3 CH double bond CH2 in presence of HBr, and you give peroxide, okay, peroxide, then what is the product? In that case, if you use peroxide, so like you use benzoyl peroxide, you can use benzoyl peroxide, you can use hydrogen peroxide, whatever, any kind of peroxide. In that case, what is the product? Okay, in that case the product is just means exchange, okay, means if you write the products here, okay, for this, if you write the product here, then you get CH3 CHBr CH3 plus CH3 CH2 CH2Br. Now this one is the major, okay, and this one is minor, okay, this is minor one, this is major one. One thing you have to remember, that this is according to the anti-Markovnikov rule. Okay, we know that in anti-Markovnikov rule, if we use a peroxide, then the negative part will attack into that particular carbon atom of the double bond system which has higher number of hydrogen atom. Okay, and this is nothing but your anti-Markovnikov rule or peroxide effect, or you can say Kharash effect. Okay, so this is the preparation of haloalkane from unsymmetrical and symmetrical alkene. For the case of symmetrical, it is very simple. So you can use means give the negative part of the halogen acid to any one of the carbon atom which is symmetrical. Okay, but in the case of unsymmetrical, you have to remember that Markovnikov and anti-Markovnikov rule. Okay, next one is also important. So next one is from the halogen exchange. Okay, D is the halogen, okay, halogen exchange. So in halogen exchange there is two different types of reactions. One is Finkelstein reaction, another one is Schwarz reaction. We have to study these two name reaction, and these two name reaction is a very important for your board examination as well as for your entrance examination. Finkelstein and Schwarz reaction. Okay, so this is the reactions. So by the reactions of halogen exchange, we also prepare that Finkelstein haloalkanes by using Finkelstein reactions and Schwarz reaction. So these things are written here. Finkelstein reactions, in Finkelstein reactions use RAX, okay, when reacted with the sodium iodide in presence of acetone and followed by reflux, and you get Ri as product and NaX is the byproduct. And you have to remember one thing here, that here X is chlorine and bromine. Okay, so here if you take any kind of alkyl bromide and alkyl chloride, that will be replaced by iodine. Okay, that will be replaced by iodine and you get alkyl iodide. Okay, so these things are the halogen exchange. See, here you have Cl or bromine, that will be replaced by iodine, so this is nothing but the exchange. Okay, so this is nothing but halogen exchange reaction. And after that, see, CH3CH2Br, this is an example. Okay, this is the main reaction. So you can say in the case of Finkelstein reaction, when alkyl means haloalkane, means like where X is the chlorine and bromine, reacts with sodium iodide in presence of acetone followed by reflux, then you get Ri as a product and NaX is the byproduct, where here X is the chlorine and bromine. This is Finkelstein reaction. Okay, and here I give you two examples. Say if you have CH3CH2Br ethyl bromide reacts with sodium iodide in presence of acetone followed by reflux, you get CH3CH2I, that means ethyl iodide and sodium bromide as byproduct. Very similarly for the case of ethyl chloride, and you get ethyl iodide and sodium chloride as a byproduct. Next one is Schwarz reaction. See, in the case of Schwarz reaction, what you have to use? CH3CH2X. Okay, here X is equals to bromine and iodine. Okay, sorry, bromine chlorine, this is used. So bromine chlorine and iodine you also use, then that will be replaced by fluorine. Okay, by fluorine, and you get the fluoride product. Okay, CH3CH2X, where X is the bromine and chlorine, that will react with mercurous fluoride or silver fluoride or antimony trifluoride or cobalt fluoride, then you get CH3CH2F. Okay, this is nothing but Schwarz reaction. So in the Schwarz reaction, you can say when alkyl halide reacts with mercurous fluoride, okay, or silver fluoride, or you can say antimony trifluoride, or you can say cobalt fluoride, then we get the alkyl fluoride. Okay, and this reaction is known as Schwarz reaction. Okay, after that, the reaction that is the preparation of haloalkane from silver acetate, and this reaction is nothing but Hunsaker reaction. Okay, and this reaction is also important. See, in the case of Hunsaker reaction, silver acetate reacts with bromine in presence of carbon tetrachloride, bromomethane will form. Okay, bromomethane will form with a byproduct of carbon dioxide and silver bromide, and this reaction is known as Hunsaker reaction. So in this way you prepare haloalkanes. Okay, so in the next part, that is in the part 3, we will study that how can you prepare haloarenes and what are the chemical reactions of haloalkane and haloarenes. Okay, so up to this, I think you enjoy the video, and just note down these things. Go through with these things, and whatever the reactions, how can you prepare haloalkane. These things are important for your board examination as well as for your NEET examinations and JEE examinations. So just go through, just follow these reactions. These are very important. Just go through this. Okay, if you understand, and if you not understand if facing any problem regarding this thing, just comment in the comment section. And if you like the video, like it and share with your friends, and to subscribe and the channel, so that and also press the bell icon so that you get the notifications. Okay, thank you very much.